In this lecture, you'll learn about RF, that's radio frequencies, and channels. Wi-Fi services operate in the 2.4 gigahertz and 5 gigahertz frequency spectrum. That's allocated for ISM, industrial, scientific, and medical use. You'll see more about what that means in a second. Because of this, a radio operator's license is not required, and ISM, industrial, scientific, and medical use devices do not have regulatory protection against interference from other users of the band. So let's see what this means. So I will open up a chart here. This is the radio frequency allocations in the US. So this is controlled by the government. And here you can see all of the frequencies that are assigned to the different types of radio communication. For example, you can see that for FM broadcasting for radio, that is 88 to 108. You can also see maritime communications in here, fixed satellite, etc. And right in the middle here, you see industrial, scientific, and medical. So it's the industrial, scientific, and medical that is used for the Wi-Fi communications, but there's loads of other types of communications happening over the airwaves as well. So taking the FM broadcasting as an example, if you wanted to set up a radio station in your area, well, you can't do that and then just start broadcasting on a particular frequency in this range. It's regulated by the government. So you would have to apply for a license to do that. And one of the things that the local authorities will do is they'll check that nobody else is using that frequency. Because if you think about it, like if, for example, my local radio station back home, they broadcast on 96.9. If somebody else started broadcasting on 96.9, then those two signals would interfere with each other. You would be hearing both stations at the same time. And of course, if you're hearing both at the same time, then neither one of them is going to make sense. So that's why there is the regulatory compliance in all of these other bands to make sure that people are not stepping on each other's toes. But for Wi-Fi networks, well, everybody's got a Wi-Fi network at home. It wouldn't be practical for everybody to have to apply to their local authority to use a particular frequency in their home. So because of that, really, it's unregulated, and anybody can use any frequency that they want as long as it is in these industrial, scientific, and medical ranges. So it's not regulated, which means it's easy to get set up, but it does mean that there's a pretty high chance that we're going to get interference. So let's talk about that more as we go through the lecture. So I'll go back to the slides again. Before we talk about the radio frequencies more, let's talk about the standards and how they have evolved over time. So the standard for Wi-Fi communications is IEEE 802.11. That first came out in 1997 and operated in the 2.4 gigahertz frequency range. And the maximum bandwidth was 2 megabits per second. So it was pretty slow. So not long after that, in 1999, 802.11a and 802.11b both came out. 802.11b also operates at 2.4 gigahertz. 802.11a is 5 gigahertz. And the maximum bandwidth with 11b is 11 megabits per second. For 802.11a, it was 54 megabits per second. So that did give a pretty good speed increase. Then in 2003, 802.11g came out. That also operates at 2.4 gigahertz. And because it's operating at 2.4 gigahertz, this can be backwards compatible with 802.11b, which is also 2.4 gigahertz. 802.11a is 5 gigahertz, so A and G are not compatible with each other. Now, with the backwards compatibility, maybe you had a wireless device which only supported 802.11b, did not support 802.11g. Well, in that case, if you had some devices on your network which did support 802.11g, then they could operate at up to 54 megabits per second. The old devices which only supported 11b, they could operate up to 11 megabits per second. In 2009, 802.11n came out, and it's capable of operating at both 2.4 and 5 gigahertz. Big speed improvement there, up to 600 megabits per second. And because it supports 2.4 and 5 gigahertz, it's backwards compatible with A, B, and G. Again, if you've got older wireless clients which only supported A, B, or G, they would only get the speed that was supported there. But if you did have a wireless client that supported 802.11n, up to 600 megabits per second there. And finally, in 2013, 802.11 AC came out. It's at 5 gigahertz. It supports up to 3500 megabits per second, and it is backwards compatible with A and N. Because it's 5 gigahertz, it's not compatible with the older 2.4 gigahertz only standards. Cisco access points support all standards. So if you've got a Cisco AP, it's not like you have to pick and choose just one of these. You can have multiple different options here, all enabled on the AP at the same time. Okay, so let's look at the 2.4 gigahertz spectrum. And the 2.4 gigahertz spectrum, it's a spectrum. It is a range of frequencies. It's not just exactly 2.4 gigahertz. It actually ranges from 2.4 to 2.4835 gigahertz, or 2.4 to 2.497 in Japan. And that spectrum, so that frequency range, is divided up into smaller 22 megahertz ranges of frequencies, which are called channels. So a channel is just a range of frequencies that can be used for your Wi-Fi. Each access point operates in one channel. And as you can see in the diagram here, some channels overlap and can cause interference with each other. Just like if we had two radio stations which were playing out music at the same frequency, they are going to be on top of each other. It's causing interference. So you can see here that channel 1 is shown in blue. It goes from there to there. And then channel 2 goes from here to here. So there's a lot of overlap between channel 1 and channel 2. Also, channel 3 is overlapping there as well. And you can see it's all the way until we get up to channel 6, where it is not overlapping with channel 1. So in the 2.4 gigahertz spectrum, in the US, there's actually only 3 channels which do not overlap with each other. Those are 1, 6, and 11. So if you've got neighboring APs, you want to use non-overlapping channels to make sure that they don't overlap with each other. Okay, looking next at the 5 gigahertz spectrum. 2.4 gigahertz channels are 22 megahertz wide. 5 gigahertz channels are 20 megahertz wide. And they have less overlap than the 2.4 gigahertz channels, so it's not such a problem here. Neighboring APs should still be separated by at least one channel, though, to reduce the chance of interference. With the 5 gigahertz spectrum, channels can be bonded. So with single channel, it is 20 megahertz wide. You can bond 2 together to make it 40 megahertz wide. You can bond 4 together to get 80, and you can bond 8 together to get 160. And that multiplies the data rates by 2, 4, or 8, depending on whether you're going for 80 or 160. So let's have a look at that. So you can see the 5 gigahertz spectrum. Here are all the different channels up here at the top. So if we're just using the single channels, we're not bonding at 20 megahertz. You can see we've got channels 36, 40, 44, and so on. We could bond channels 36 and 40 together. That would double it to 40 megahertz, and that's going to give us more bandwidth, more throughput there. We could double that again at 80 megahertz. That would be channels 36 to 48, or we could go up to 160, which would be 36 all the way up here. Okay, so that was the 5 gigahertz spectrum. Now, I have been talking in this lecture about the interference. I mentioned about how the ISM band is unlicensed, so you do not have any guarantee that the frequency belongs to just you. In actual fact, it's unlikely that that is going to be the case. And many devices can cause interference in the 2.4 gigahertz spectrum, such as microwave ovens and wireless video cameras, fluorescent lights, and baby monitors. Comparing 2.4 and 5 gigahertz. 2.4 gigahertz has got greater range. It goes further. It's also got better propagation, meaning it gets through obstacles better as well. But the 2.4 gigahertz range is more crowded There's more things there, more chance of having interference. 5 gigahertz, 802.11ac has higher throughput than is available with any of the 2.4 gigahertz options. So you might think, well, then for sure, I'm going to be using 802.11ac, but your client stations might not be compatible with it yet. They might only be compatible with 2.4 gigahertz, which would force you to use that or to upgrade them. Because of all the potential for interference, site surveys should be carried out for Wi-Fi networks. The purpose is to find the best placement of access points for maximum coverage of the required area and minimum leakage outside it. You want wireless to be available everywhere you want it inside the building. You don't want it going outside the building because that would be a security concern. The site survey is also going to discover potential sources of interference as well. So the way that you do this is you use some software on your laptop. You can walk around the building, and this software is going to detect any potential sources of interference. It can also help you with the AP placement as well. And a wireless LAN controller can manage the channel allocation and the power level of the APs to get the best wireless quality. And let's have a look at an example of using some software on my laptop, which can give me information about the different wireless frequencies in my area here around about my house. So I have got some free software called Insider open here. I've just opened it and you can see it is monitoring the wireless frequencies right around my laptop here. And you can see that I've got home Wi-Fi available. That's my home wireless network here. And that is supporting 802.11ac. So that's great. It's the latest standard. And you can see it's available on both 2.4 gigahertz and 5 gigahertz. And round about me, nobody else is operating at 5 gigahertz. So that's great. I should get really good quality there. But if I connected my laptop at 2.4 gigahertz, you can see there's all these other wireless networks round about me as well. And you can see that the channels are all overlapping down here. So to minimize the interference when I'm connected over wireless, I'm using the 5 gigahertz range. Okay, that was everything I wanted to show you here. See you in the next lecture.